Hello everyone. So today we will be learning about the poles and zero of a circuit and how to realize them intuitively, right? The first part will include only intuitively realizing them for the first order circuit. Now if this video gets more likes and views, then I will try to bring it for second order circuits. Okay. So first thing, what few key points we need to remember is before going into the intuition, right? Few key points which I want to tell. First one is basically if we have two series impedances of opposite sign, then the equivalent impedance will be a short circuit, basically a zero impedance, right? I know this seems a bit easy from here, but when you go on to find the poles and zeros, right, then this doesn't seem so obvious at that situation, right? That's why I am to focus on this right now. The next point is if we have two impedances which are parallel to each other and are of opposite sign, then the equivalent impedance will be a infinite, right? You can do it for yourself. Basically, what is Z equivalent? Z equivalent is Z times minus Z divided by Z plus minus Z, right? And the denominator becomes 0, hence this equivalent impedance blows up, which goes to infinity, right? So let's take an example. Here we have one R and C, and how to find the infinite impedance, right? Seeing from here, basically we have to negate this, right? So what do we mean by negating? R should be equals to minus 1 by Cs. So what is S in this case? S will be basically equal to minus 1 by RC. So this will be the value of frequency for which we get a equivalent infinite impedance, right? This is just an example, just to start you off with what we will try to do. Okay, now next is we'll know what is a transfer function and how to write it. So we write the transfer function in this format, right? Basically output by input, and please keep in mind that a transfer function can be anything, it can have any unit, right? Generally we'll write the transfer function as a ratio of voltage, output and input voltage, but it can be like a resistance also, it can be conductance also, it can be no unit also, don't have any unit also, that is also possible. So it all depends on what we are taking as output and what we are giving as the input source, right? So but the format should remain same. Format will look something like this. This is A is basically the DC gain of the circuit, and then we have the zeros, right? Zeros in multiples, and then in the denominator we have the poles. So omega z1, omega z2, all these are the zeros, and omega p1, omega p2, all these are poles. So this is the basic format of transfer function that we will write. So this is just for our ease when we get to the answer, right, from our intuition, to write this in this format, so it will be much easier for us to identify poles and zeros. So now one thing is, if there is a 0 at s equal to 0, right, at s equal to 0, if there is a 0, then we can't find the DC gain, right? The DC gain will be 0, right? Because if there is a 0 at s equal to 0, we put s equal to 0 and the transfer function becomes 0, right? So how do we find the value of A? How to determine the value of A? The A can be determined with the help of high frequency gain. Like if we put s equals to infinity, right, s tending to infinity, not equals to infinity, then we will be able to find the value of A. I will let you know when we get to that stage. You will be able to understand what I am talking about. Now let's take an example. Here, exactly what I was talking about. Here there is a 0 at s equal to 0, right? Now if we put s equal to 0, then we won't be able to find the DC gain, right? So what we will do, we will just put s equals to infinity, s tending to infinity. Now if we do limit as s tending to infinity, right, for this h of s, so basically what will happen is only the coefficients of s will remain. S themselves will cancel out, but the coefficient of s will remain. And one thing is that the question has stated that h of infinity is 1 by 2. So if h of infinity is 1 by 2, then we have already found out this value a omega p, right, from here. So A should be equals to 1 by 2 omega p, right? So this is the value of A. That's how we will find the value of A, just like this example, right? Now next, what this says that as I told you earlier, if h of 0 is 0, then there is a 0 at s equals to 0. If h of 0 is infinity, right, then there is a pole at s equal to 0. I will tell you what is a 0, what is a pole. I will let you know later. If few people who already know about them, then they can relate, right? What is pole? Pole is basically when we get a infinite gain, right, at that particular frequency, and 0, the name like says for itself, when we get 0 gain at that particular frequency. So if h of infinity is 0, the number of zeros is less than the number of poles. Basically at infinite frequencies, if we are getting a 0 gain, right, then the number of these zeros, right, at the numerator will be less than the number of poles. Poles will be more. That's why at infinity this whole equation will go to 0. And if h of infinity is finite, the number of zeros will be equal to number of poles. Okay, but if number of zeros is greater than number of poles, then system will be unstable at high frequencies, which is like generally in real case, right? We don't have a system where the number of zeros is more than number of poles, and the system won't be stable. Okay, so please do keep this in mind. So next is, what are the significance of poles? Like what do pole define? Pole define the order of the system. Okay, what is the order of the system? How many independent energy storing element are present in the system? Poles define that. Poles describe the stability of the system. Basically, if the poles lie on the right half plane of the j omega axis, right, of the s plane, then the system will be unstable. And if they lie at the left half plane of the j omega axis, then pole will lie the system will be stable. What do you mean by right half plane and left half plane? Basically this, right? This is the j omega axis, this is the sigma. So if poles lie somewhere around here, right, system is unstable. If pole lies somewhere around here, then system is stable. Okay, so I hope you have studied control system enough to like revise this. I'm just revising you a bit of things, right? Now one more thing, poles describe the performance and speed of the system, right? Like how fast the system reacts, how fast the system acts. Also, like one more thing for poles is that poles tell about the time constant of the circuit. As here, like I have mentioned, right, it is telling about the speed, right? So what is poles? Poles will be equals to basically the negative of 1 upon magnitude of the time constant, right? This will be the value of the poles, right? So by this method also you can find the poles of the circuit. Also, poles describe the type of the system. Okay, what order and type, they are almost same. Okay, that's just for the like terminology. I just need to mention this. So all these things are done. Now let's come back to a real thing, which is finding poles and zeros intuitively. So first we have one RL circuit, right? So how can we write this RL circuit? We can equivalently write this RL circuit something like this. Okay, as impedance here, Z1, Z2. This is the input we are providing, and this is the output we are taking, right? Now how can we write the output voltage, right? Output voltage can be written as just a basic voltage divider, Z2 divided by Z1 plus Z2 into Vi. Okay, this is the basic like equation of like output voltage. So what is the V over Vi ratio? What the V over Vi ratio will be this, right? Z2 over Z1 plus Z2. This is basically H of S, right? So all these are function of frequency, Z1, Z2. So this is basically the H of S. Now let's go, what is a zero and what is a pole? So for zero, first, what is the definition of zero? Definition of the zero is basically the magnitude of the voltage should be zero at a finite frequency or at any frequency, right? For a finite value of input voltage, right? The input voltage should be finite. So how can we find the zero? So V over Vi equals to Z2 over Z1 plus Z2. How can we get zero for finite Vi? So for finite Vi, if this goes to 0, right, then we'll get a 0. Okay, or one alternative thing can be happen is that if this Z1 goes to, also one more thing is that when this goes to 0, right, like this Z1 cannot go to 0. Why it cannot go to 0? If Z1 goes to 0, then what we will get? We'll get 0 divided by 0 plus 0, which is just 0 by 0 format, which is undefined, right? So we can't certainly say that the the VO will be 0, right? Why? Because if we draw the circuit, right, this is 0, this is 0, this is VI, and we're taking VO. What is the current through the circuit? What is the current through the circuit? The current is infinite, right? VI over 0, it's basically infinite. Now if infinite current is flowing through here, right, infinite current, so infinite times this 0 drop is not equal to 0. We can't say that, right? So if you want to understand it in both ways, I'm saying you to in both ways, basically 0 by 0 format or infinite times 0. Both these things are not possible to find out, right? So I have understood you this one, why Z1 and Z2 can't be equal at the same time. So basically first condition, right, for 0, first condition is if Z2 equals to 0 and Z1 is not equals to 0, right? Very important. So this is the first condition. Now let's this is also known as short the output, right? Short the output voltage. Okay, now next is break the link. What do I mean by breaking the link? Basically, if this goes to infinity, if this value goes to Z1 goes to infinity, then this whole like equation will go 0, right? Now like what is the other condition we should follow is if this Z2 is also not equals to infinity, right? This Z2 should not be infinity. Why? Again the same thing, right? Again if you write infinity over infinity, we can't say like what will be the value. Okay, so that's why we're getting an undetermined format, and if both of them are 0, right, Z2 and Z1 both are 0, then there will be pole 0 cancellation and there won't be any pole or 0 at that location of the frequency, right? So for this condition, break the link. Z1 is infinity and Z2 is not equals to infinity, right? So I am drawing the circuit diagram for both these cases, right? So the first diagram is something like this. This is Z1, this is shorted, this is VO, and this is VI, right? A finite current is flowing through this, VI by Z1. Finite current is flowing through this. So if finite current times this 0 impedance will be 0 voltage. Now for the second case, right, if I draw the circuit, I have space. Okay, if I draw the circuit, basically we are breaking the link, and this is Z2, and we are taking the output from here and the input is here, right? So what is happening? Basically like there is infinite impedance, so there won't be any current flowing through this. Now this Z2 is finite, right? Z2 is finite, so this is 0 amps of current, so 0 times Z2 equals to V0, which is equals to 0 volts. So we are getting a 0. If Z2 would have been infinite, then there would have been an issue. We wouldn't be able to tell what the value of V0 is. Okay, so I hope I have made these two things clear for zeros. Now let's go to poles, right? So like for poles, what do we have is, for poles, let me write down a transfer function first. Z2 Z1 plus Z2, right? Now this is Z2. So for poles, what do we need? We need that the output voltage should go to infinite without like for a finite value of Vi, right? For a finite value of Vi, how will that happen? Only due to this condition, right? Only if this goes to like if Z1 plus Z2 goes to 0, then only we'll get infinite gain, right? The VO will be infinity. So the condition is Z1 equals to minus Z2. Okay, now what other things we should keep in mind? Other thing we should keep in mind is that both Z1 and Z2 can't be equal to 0, right? If Z1 equals to Z2 equals to 0, then what will happen? Then we will get Z2 0, Z1 0 plus 0. Again we are getting the same thing, 0 by 0 format, which is undeterminate, right? So basically what will happen is we won't be able to find the poles for this. There will be pole 0 cancellation in this case, and there won't be any pole at that frequency. So basically this is the condition. So what this also tells us is that there has to be infinite impedance, right? Remember, like first thing, if this is Z1 and this is minus of z1. So and let's assume like we are shorting the input in like deactivating the input, and this is 0, this is VO, right? Now remember what I told you in the earlier, that if this is z1, this is minus z1, then we'll get infinite impedance. That's what we need to do is, right, we need to make infinite impedance between VO and ground. Like this is also another method of doing it, okay, another method of doing it, and this is also another method. Both of them are telling the same thing, right? So basically you can do it in either ways, okay. So next is, let's go and like do a few circuits. Let me draw this a bit well, like so that you will understand it. Okay, let me keep this undefined. Also let me write this, that z1 is not equals to z2 is not equals to 0, right? This is important condition. So this is another way to find out. Basically this is z1, we are shorting the input, this is z2, and this is VO, and as z1 equals to minus z2, then we are getting infinite impedance, okay, infinite impedance. Now basically let's go to the like next slide and do few circuits, okay. Also how we are getting the output voltage as infinite, let's see that, okay. So this is Vi, this is z1, right, this is z2, and this is VO. So what is the current? The current is basically Vi by z1 plus z2. Now as z1 plus z2 is 0, so I will be basically infinite, right? Now this z2 is finite, right? Z2 is not 0. So a finite current, finite impedance times a infinite current, right? The output voltage will be basically infinite, which is basically I times z2, right? As z2 is finite, we are getting infinite voltage. So this is how the like the pole like states us that the output voltage is infinite. Now let's go to few examples. So this is the basically the first example, which is a basic RL circuit. So first let's go for the calculation of zeros. So for zeros, right, what we can do is, let's first do like first thing, break the link is not possible. Why? Because z1 can't go to infinity, as this is not a function of frequency, so that thing is gone. Next is short the output, right, short the output. So if we short at s equal to 0, this becomes shorted, right? So this becomes shorted, so V0 will be like 0 for finite Vi. So at s equal to 0 we have a 0, okay. So break the link not possible, so we have only 1 0 at s equal to 0. So what about the poles? What are the poles? So for pole, right, we have to make this is the z1, this is z2. Z1 equals to minus z2, which is basically R equals to minus SL, or S equals to minus R by L, okay. So this is the pole, this is a 0. We don't know the DC gain, because at the starting I already mentioned that DC gain can't be found out when we have a 0 at 0, okay. So let me write the transfer function first. So H of S equals to A times S divided by 1 plus S into L by R, right? This is a time constant. So let us find the like infinite gain. I need another page. So for infinite gain, right, what is the infinite gain? Infinite gain is equals to basically VOA equals to 1. How are we getting it? At infinity, right, the inductor will be open circuit. Why? At s equals to infinity, the impedance becomes infinite, so this is open circuit, this is R. So current through this is 0, current through here is 0, hence Vi equals to VO, right? So Vi equals to VO, hence this equation comes up, VO by Vi equals to 1. So at H of infinity we are getting 1 as gain. So if we put that s equals to infinity in that equation, right, putting that s equals to infinity in that equation, we get as only the coefficients of s will remain. So L by R equals to 1, so A equals to L by R. So what are we getting as the transfer function? Basically S L by R 1 plus S L by R. Now this is easy. Basically, if you do this without the intuition, right, you can easily find it out. But in the next few circuits, it will be a bit difficult. Okay, just to find it out from normal like calculation, voltage division rule and all that. So the next circuit is also very simple. I will do this a bit faster. Basically, what is that, like the 0 for 0, right? For 0, can we break the link? Yes, we can. At s equals to infinity, it is going to 0, but the problem is like it isn't a real 0, hence we can't plot this in like real frequency axis. So s equal to infinity, we are not getting a real 0, right? Real 0. Can this go to 0? No, because this is not a function of s. So for 0, we don't have any real zeros, right? Now let's go for the poles. For the poles, right, what we can do is basically make z2 equals to minus z1. We'll get the same value, right? We'll get the same value, which is s equals to minus L by R. Okay, minus L by R. So now what is the DC gain in this case? DC gain is 1 in this case. Why? If at s equal to 0 we put the circuit, this inductor will be short. Okay, this is R, this is Vi, this is Vo, right? So Vo equals to Vi. So DC gain is 1, hence A will be equal to 1. So what we will get? Basically 1 divided by 1 plus S L by R. This is the transfer function. Now let's go to the next one. So this is also kind of simple only. Let's first find the zeros. Okay, for zeros, what we need to do is see if we can break the link. Currently I am not seeing how to break the link first, so I will go for the short circuit, right? So if I can put s equal to 0, right, s equal to 0, this impedance is finite. So what is the z1 and z2 here? Z2 is this and z1 is this. Okay, so if I put s equal to 0, this impedance goes to 0, hence this is sorted, right, to ground. So V0 goes to 0 as this is finite. Z1 is finite in this case. So at s equals to 0, we have a 0. Omega z equals to 0, right? We have 1 0. Now can we break the link? We can't, right? We can't, because this isn't a function of omega, so this never would go to infinity. So let's go to the pole. So for pole, what we need to do is basically make z1 equals to minus z2. Now I will solve this using the second method, right? I will short the input and make this equivalent impedance infinity. How to make this infinity? Basically the denominator should be 0. All these are in parallel, right? All these are in parallel. Now if I write the admittance of this, so if the admittance is 0, then the impedance will basically be infinity, right? So what is the admittance? RL. Admittance is 1 by R plus 1 by R plus 1 by SL equals to 0, which is 2 by R equals to minus 1 by SL, or S equals to basically S equals to minus R by 2L. So this is the pole value, right? So we have got a pole. There will be single pole. Basically this is like a first order circuit. So the pole will be 0, right? So let me write the transfer function. So the transfer function h of s, right? For that we have to find the DC gain. What is the DC gain? Again we have got the like a 0 at s equal to 0. So for DC gain we will take help of the infinite frequency. So for s tending to infinity, right, what is happening? Basically we have this Vi over here and this is infinite. So the impedance will be infinite. A finite like resistance in parallel with infinite impedance, we will only get this finite resistance, right? So this two are in series, hence there will be voltage divider, hence this output will be Vo by 2, right? Simple voltage divider. So what is the gain? Gain is basically equals to 1 by 2. Vo by, it's getting not Vo by 2, it's Vi by 2. Okay, so as we are getting 1 by 2, so what is the transfer function? There is 0 at s equals to 0, then there is a pole at s equals to minus R by 2L, which is basically 2L by R. So at s equals to infinity, this becomes a upon 2l by r, which is 1 by 2. So a equals to l by r. So what is the transfer function? The transfer function is l by r times a divided by 1 plus s 2l by r. So this is the, sorry, this is not a is basically the values times s. This is the transfer function for this given circuit. Now next, go to the next circuit. Again, let's go first for the zeros. For zeros, if I observe is, if I make s equals to 0, right, if I make s equals to 0, then this also becomes 0. Like, remember from our first condition, the z1 should not go to 0. If z1 also goes to 0, then we will have a 0 by 0 format, then it will be difficult, it will be undetermined, right? So s equals to 0 is not possible for a 0. Now next is, if we break the link, right, if we break the link at s equals to infinity, what we are getting is, this is getting infinite and this is getting infinite. From here we're taking the view, right? So this r is finite, right? So this is infinite, but this r is finite, hence the current through this is 0, hence the drop is 0, hence v0 is getting 0. So at s equals to infinity, we have a 0, but this is not a real 0, hence we will not have the 0 in the transfer function, right? Now coming back to like the poles, for the poles, right, how to find the poles. So for poles, we have to basically make like z2 equals to minus z1. So what is z1 in our case? Z1 is SL. What is z2? Z2 is this whole thing, right? This whole thing. This is basically a parallel combination, r times SL divided by r plus SL, right? So we have to basically equate that, addition equals to 0. So SL equals to minus r SL divided by r plus SL. So SL cancel each other out. We are being remained with basically 2r equals to minus SL, or s equals to minus 2r by L. So this is basically the like the pole, right? This is the pole. We have got the 0. Now let's find the DC gain, right? So what is the DC gain? So DC gain, we have to put s equal to 0. Now earlier we like skip this part. At s equal to 0, we can't be able to find a 0, right? As we can't be able to short this, because this is also becoming 0. So how the circuit will look like? The circuit will look something like this. R won't be present because at parallel we have a much lower impedance than R, right? So this is 0, this is 0. So what is the DC gain? DC gain is basically the series division of these two, right? Series division of these two, as these two are in series combination. So this is the VO, right? So VO will basically be equal to 1 by 2 times VI. So VO by VI is 1 by 2. So the DC gain is 1 by 2. So what is the transfer function, right? So the transfer function is basically 1 by 2, 1 plus S. We have the pole at minus 2R by L. So this is L by 2R, right? So here we have next question. So this is basically similar types of question only. Can we make this time like short the output, right? Can we? We can't actually. If we again short this, right, this is Z2, this is Z1. If we again short this, then the equivalent circuit will look something like this, and the gain is not 0 at the stage because Z1 is going to 0, hence we can't short the output. Can we break the link? Here if we do one thing, right, like this is a parallel combination, right? If two parallel combinations are present, how to make infinite impedance, as I mentioned in the prerequisite, right? Basically negate the other one, right? If we negate the other one, then we'll get a infinite impedance. So S equals to minus R by L. Or if you couldn't understand this, basic is this is the parallel combination, right? So what is the parallel combination? R plus SL equals to Z, right? So how to make this infinite? Basically make this 0, denominator 0, then this will become infinite. So R plus SL equals to 0, S equals to minus L by R. Okay, so now at S equal to minus L by R we have a 0, right? Why? As this is infinity, but this is not infinity, right? This is some finite value. So we will get a 0 at s equals to minus L by R. Now as we like skipped this part, right, for the DC gain calculation, again the DC gain will be similar only. Basically VO will be equal to VI by 2, okay, as I like mentioned in the previous circuit. Now let's go for the poles calculations. So for pole, right, what we have to do, we have to basically make this negation of this, right, make infinite impedance up here. So what is the equivalent impedance we are seeing? Again I'll solve from that other method, right? So what we have to do is like adapt from like circuit to circuit which method is suitable for that particular circuit, right? This is V0 and these three are in parallel, right? We're shorting the input, so we have to make infinite impedance, that is the admittance should be 0. What is the admittance? 1 by R plus 1 by SL plus 1 by SL equals to 0. So again equating this, 1 by R equals to minus 2 by SL. So S equals to minus 2 by 2R by L. So we have got a pole, we have got a 0, we have got the DC gain. Here A equals to half, so we can easily write the transfer function is equals to 1 by 2 divided by, there is 1 0, right, 1 plus Z times L by R, 1 plus S times L by 2R. Okay, this is the pole, this is 0. So this is the basic the transfer function of the circuit. So I have finished 5 examples here. I will finish more examples in the next video. Okay, thank you for watching.